When we first learned about pointers and I asked for exercises, there were quite a few exercises that would have been relevant to pointers that we couldn't quite do because a lot of uses of pointers that show up in practice also involve arrays or strings. But now we know about arrays and strings, and so why don't we go back around and ask for more exercises that give us practice with pointers? And today, I'm particularly interested in practice involving pointer arithmetic, which is something that we didn't see initially when we first talked about pointers, because you don't really need to do pointer arithmetic until you're working with programs that somehow involve arrays. I would prefer, in general, to get some pointer arithmetic exercises that involve strings for a variety of reasons, one of which is, I guess in my opinion, pointer arithmetic is very useful for other types of arrays, but I'm wondering whether the exercises that ChatGPT gives me for those are either going to be a bit unnecessary, so that is using pointer arithmetic to do tasks that we could do easily with square brackets, or way too complicated. So I'm going to declare that bias going in. I am still going to ask it for exercises in general involving pointer arithmetic, but I reserve the right to focus it in on string-related exercises. I want some practice with pointer arithmetic in C. Can you generate 3 practice exercises involving pointer arithmetic? Now, I really liked what we got in the last video where it provided me a bunch of functions to implement and a main function with a little bit of testing code. We shouldn't go our entire lives only writing code that way, but I feel that for this purpose, for pointer arithmetic exercises, that's going to be pretty helpful. To stick everything inside of a function and have all the exercises together, I think made everything a little bit more convenient last time. So I'm going to ask for that. I would like all of the exercises to take the form of functions to implement, where you provide a main function which tests all of the functions I need to write. And those functions are left blank. Okay, so I don't think I'm going to bias it too much as far as the content of the exercise by saying this. I'm just describing the format that I want. I would like a mixture of pointer arithmetic exercises involving arrays, not strings, as well as exercises involving strings. So I want to do I want to practice pointer arithmetic in a variety of different settings. And I'm going to remind it, as usual, don't show me the solution to the exercises. Now, this is actually a bit of a wall of text, and I don't think it's that clear, so if it can't figure it out, I don't know if I blame it. I still might blame it, though. Okay, of course, I'd be happy to help. Let's just go take a look at what it's saying. Here are some pointer arithmetic exercises. Okay, it's getting pretty eager. It wants to keep scrolling down. Remember to implement the functions and test them using the provided main function. Okay, that's not too surprising. Okay, we've got array sum. Okay, so this is something that I would probably do without pointer arithmetic, but okay, I'll play along, I can do that. Array copy. Okay, that's interesting. Yeah, sure, why don't we do array copy? String length using pointer arithmetic. Okay, yeah, this is in some of the other examples, but sure, I'll do that. So I actually sort of like what it's come up with here. And then there's a main function containing some test stuff. I like that so much that I'm actually going to ask it to extend it. I really like those. Can you add a couple of extra exercises as well? It gave me 2 regular array exercises and 1 string exercise. And for what it's worth, I think the string exercise was a bit, I don't know, simple or something. So I'm going to ask it for more string exercises with both extra. Can I add? Okay, I'll rephrase this. A couple of extra string exercises as well. Oh, I didn't put a question mark. Hopefully it figures that out. Okay, so it's generating a new template here. I'm getting pretty demanding with it, but I'm gonna do this. So, can you combine both sets of exercises into a single program? All right, I think it can do that. It does seem like it's pretty good at these formatting requests. Okay, so we'll let it finish typing everything out, and then we will copy that. Okay. Now, as we saw in the last video, it seems like its idea of a specification for these functions is pretty minimal, and so we're just going to have to work around that. And I think because we're using it as a tool to help us practice, obviously we don't, maybe designing our own specification is sort of good practice anyway. So, okay, I've got array sum, I've got array copy, and I would argue really these are sort of self-explanatory what we're being asked to do here, or at least I can figure out pretty easily what I think it needs. So these are integer array exercises. Then I want to compute string length. This is strcat, so this is the string concatenation function, the pointer version, which frankly, I have already done in a different video, but whatever, we'll do it again. And then string comparison. Ooh, and it doesn't give a good specification for string comparison, so I'm going to have to ask it to clarify that. Can you give a, can you actually, I'm going to ask it to formally specify every one of those functions, because let's see what it can do there. Can you rewrite that template and add a formal function specification for each function? I'm just going to remind it, don't show me the solution. Okay, we'll see what it comes up with. All right, yeah, so it's going to come up with something that's a great deal more closer to what we expect in a course like this. So I'm actually going to use this version of the template. Oh, okay. So it's decided to decided to phone it in on the main function, but I guess we can duplicate the main function from earlier. Okay, so I'll paste over the previous set of functions. Okay, it didn't copy. I hit copy code. There we go. I'll try pasting it again. Get some nice dead air while I do that. Okay, it's still not copying and pasting. Really? Do I have to? There we go. It says copied. Why is this the thing I have to fight with it about? Okay, so then I go back over here and I try and paste it. Okay, there it goes. So I'll delete the main that it gave me. I really hope that it understands that I wanted function signatures to say the same as the previous version, so that the main I was already given does actually work for this. Okay, why isn't, there we go, delete all of these old ones. So I'm having some kind of formatting trouble this morning. There we go. All right, so the first thing I'm going to do is try compiling the unmodified template, because that'll give me a sign of whether there's trouble brewing. It looks like there isn't. These are all warnings that I would expect from a template that I have not yet completed. Okay, so now I have exercise 1 array sum, and I've got this much more formal specification. This is pretty similar to what we see in assignments and on exams. I guess I'm not seeing type information in here, but I mean, it is present in the function signature. Array copy, string length, string concatenation, string comparison. So I'm going to have to give you, I'm going to have to give an explanation of what I do here. This is asking me basically to implement the string compare function from the library. And there's a certain quirk of string compare that you will recall in a previous video, I refused to implement this function because I didn't want to get into it, but I've run out of excuses. I guess I have to do it today. I'm going to have to give a bit of an explanation of how that works. I've posted some notes about that, but just in case you haven't read them, this is still good practice, even if you never want to use the string compare function. Okay, and then there's one other thing I want to bring up, which is it seems to have generated some pretty good test code, and we saw last time that it was pretty good at generating test code. However, I will observe, and I noticed this right off the bat, line 61 is weird. And so this is a valid trick that ChatGPT is using. It is using a certain operator of the language, the size of operator, to figure out the number of elements in this array ARR1. This is valid, so I believe this will correctly determine the size of the array. What I will also say, though, is be very careful about generalizing this example. So the size of operator, broadly speaking, doesn't usually do what many people expect it to do. It is going to work correctly in this case, but this trick, although very clever and is the kind of thing people pat themselves on the back for using, this trick in some ways can result in code that is not maintainable, because this trick only works if you use it in the same scope, or I guess in the same function where the array that you're taking the size of was originally declared. So if I take the size and later split my code up into multiple functions, this trick will no longer work correctly, and it will result in strange sort of weird weird random bugs occurring because it might not be obvious to me that it's no longer working. So just a warning about that. And when we cover size of in the lectures, you'll notice that I'm pretty skeptical of many uses of the size of operator because although it's valid and it does do what ChatGPT wants it to do here, people often use it in a way that results in lots of maintainability headaches for software. Okay, so there's my there's me pontificating about size of. Okay, let's go and implement these. I guess I should skim over the test code. So the first one is I've got this ARR1, this array here, and then I compute the array sum. It gets returned, and I print it out. Okay, so I guess I expect the array sum to be 25 for this array, and I obviously will want to test it on a few other examples as well. The way I'm going to complete this is I'm going to comment out all of the other test cases and just do one function at a time. So similar to what I guess you probably did in assignment 4 or 5, or whichever assignment was the linear algebra one. So in August, I cannot remember what number of assignment that is. So I'll comment out all those test cases, and we'll start by doing array sum. And my goal is I will use pointer arithmetic instead of square bracket array access for all of this. We already know by now, and if you don't know, you can go take a look at other videos, how to compute the sum of elements of an array using the usual array notation, using subscripting and square brackets. I'm going to, instead, I'm going to use only pointer arithmetic for this. Okay, so I'm going to need a variable to store my sum. We'll set that to 0. Down at the bottom, I'm going to return my sum. And now I'm going to use pointer arithmetic and some kind of a loop to add up all of the elements of this array. I'm going to make the editorial change I made in the last video where I move the star over to be close to the word int so that it's more obvious to me that it's part of the type. That is a sort of modification to the function signature, but it amounts, in my opinion, to adding and removing spaces. And we know that that doesn't really have an effect on the functionality of the program. Okay, so I need a loop. What I'm going to do is just count to size here. So I is equal to 0, I is less than size, I plus plus. And then inside the loop, what I would normally do if I was using square brackets is just this, ARR sub I. That would be all I need. But of course, I'm not allowed to do that. I have to use pointer arithmetic. So let's try a few variations of this. Let's first try the most obvious conversion from subscripting to pointer arithmetic, which is just adding the base pointer ARR to my index I and then dereferencing the pointer. And just I'll sketch this out for this example, but recall that what that really means is if I have this array ARR, and of course, we know that the name of the array is interpreted when I use that name as a pointer to the first element of the array. If I compute the expression ARR plus I for some value of I, let's just make up a variable I here, and I is going to be, let's say, 3. Well, the ARR plus I, this expression here is equivalent to an arrow that points, okay, so there's index 0, 1, 2, 3. It's an arrow that points to whatever location is referred to by this position, but 3 in the future, the value of I in the future. Okay, so there's the position referred to by ARR. I count ahead 1, 2, 3. So this expression here is will evaluate to a pointer to position 3 of the array. And then if I dereference it, well, that means I should be following that arrow, and that would be if I say star ARR plus I equals 6, I'm setting this element to 6. Okay, so that's the most obvious conversion from subscripting to pointer arithmetic. I would argue that this is useless, and actually arguably at this point this is deliberately obfuscating my code. I should just use square brackets if I'm going to be writing expressions that look like this. But whatever, let's just try that to begin with. So in the test case I have below in main, I expect it to say the array that it's using has a sum of 25, so I expect the output to be that the sum is 25. There it is. Okay, now before I test further, the version of my code I want to test is going to be a little bit more streamlined than this. This is not taking advantage of any of the nice properties of pointer arithmetic. I'm just using subscripting, but I'm disguising it by using pointer notation. So what I could do here is instead of using the value of I could do something like this, star ARR, and then modify the pointer ARR. And I should be careful how I phrase this, but basically there's this array that exists somewhere in main. For the sake of the example, let's suppose that the array's name is A. The example I just did made it look as if the array was created inside of this function, but it wasn't. What I'm being passed isn't the original array, because the array was created in main and belongs to main. What I'm being passed is a pointer to some element somewhere. It doesn't even have to be a pointer to the beginning of an array. It's just a pointer to some integer value, presumably one in the middle of an array. And remember that that's true even if I were to write the function signature like this. Even if I use the empty square brackets, the compiler interprets any function signature containing this kind of argument declaration as exactly the same as if I were to write this. So what I'm getting is a pointer, which becomes my local variable ARR. So inside the function ArraySum, I'll just draw out a quick scope here. Inside the function ArraySum, so there's my scoping box, I've got this variable ARR of type int star, well, of type formally const int star, which is a pointer to an array of ints that are not allowed to be modified, const ints. And ARR, as it's been passed, is a pointer to presumably the beginning of this array. But notice that the variable ARR is a regular pointer variable. I'm allowed to change it. I would not be allowed inside of main. So if I declare an array like this in main, so if I make a real array and I own the original, I would not be allowed to write A++. That isn't allowed, because A is a fixed pointer permanently pointing to the beginning of the array that it corresponds to when you create it. But what I have inside the function ArraySum is just a regular pointer variable. I can modify it all I want. So that's what I'm doing here. Each time that I iterate along, so suppose I'm adding up the elements of this array, each time I iterate along, I go and grab the element, so I dereference the pointer, star ARR, and then I do ARR++, which amounts to repositioning the arrow one element in the future. And that means as I go through, I don't do explicit indexing, because the pointer just stays, it keeps track of the next element that I want to add in. Okay, I'm going to delete my diagram and probably immediately regret it, because I'm going to want to draw more stuff. And then I'm going to run this code and see whether it still gives me a sum of 25. Okay, so I'm going to compile it again. These warnings are still there, but they're still, we can still ignore them. The sum is still 25. Okay, so I'm going to do one more test before I go further. Let's add a negative number to this, and that means the sum should be 23. Okay, I should do a little bit more testing than that. Okay, now the sum is 21. Oh yeah, right, sorry. If I do -2 here, previously the sum was 25. If I turn this to 0, now the sum is 23. If I turn this to -2, now the sum is 21. So 21 is the right answer for this. Let's also try making the array a different size. So I'll do, let's add 10, which means the sum should be 35. And notice how I actually won't have to change the size that gets passed in because of this clever trick ChatGPT used that gives me the illusion that I'm allowed to learn the size of an array. So if you're watching this, well, which you are if you can hear me, then don't assume that's what this does. A lot of people lose a lot of marks every year by trying this trick out on a midterm or something, and it doesn't work. Now, so to be clear, you'll get the marks if the trick works in the context where you use it. You're not going to be artificially punished, but this trick does not work in a lot of settings, especially inside of functions. If I were to use this inside of one of the functions above, it would fail. Now, if you want justification of that, go look at the other videos, the lecture videos, because we talk about that there. Okay, so the array sum should now be 35, so I'll run this again. And you know what I'm going to do before I go further? So my test was successful. I'm going to go into all these functions that return a value and just return a placeholder. So I'm going to return -999. I'm sick of seeing these warnings. So, okay, this doesn't need to return anything. Here's my string length function. I'll return -999. There's array copy isn't supposed to do anything, so that should get rid of the warnings. Compile that again. This warning, okay, well, we can ignore this. This is a test case that I haven't used yet. All right, so I'm not actually done with my array sum function. So here I'm using pointer arithmetic a little bit more, but I'm still doing pretty much the same amount of work that I would be doing if I were not using pointer arithmetic. So if I was using subscripting, I would be computing ARR sub I, which we know is equivalent to ARR plus I all dereferenced. So I do one addition and then I follow a pointer. What I had a minute ago is also I do an addition here and I follow a pointer. I just rearranged it in a way that makes it look a little bit less obvious. But one thing I can observe though is notice how I'm not using my variable I anymore, except for keeping track of my loop. Maybe I could leverage that to streamline things a bit more. Okay, so what I'm going to observe here is that I don't actually care what the value of I is when I'm doing my sum. All I care about is I have a loop that counts up to this number here. So now I'm going to try a trick that, to be honest, does not make the code any more readable. It probably makes the code less readable, but just for the sake of illustrating one of the benefits of using pointer arithmetic, if you're interested in cleaning up the number of variables you use or eliminating moving parts, which again isn't always a good idea. So this is almost an aesthetic discussion that I'm trying to have here. What I'm going to observe basically is I have another option for writing this loop that uses fewer variables. I could write something like this. While size is greater than 0, and then at the end of each iteration, I decrement the value of size. Now, I really hope that when you look at this, it does feel a little bit wrong. There's something about this that feels a little bit wrong because the variable size is supposed to be the size of the array. And yet here, I'm just sort of modifying it on my own in a way that is sort of irrational. But let's see whether it works. Oh, whoops, let's compile it first and then see whether it works. Okay, the sum is still 35. Let's try changing the size of the array to be 25, or sorry, so the sum is 25. There are now 5 elements. All right, that works. What happens if the array only has 1 element? Now I expect the size to be 3. Or sorry, the sum to be 3. Okay, that looks like that works as well. Let's do our favorite array here. So the sum of that should be 33. And it is. And then finally, let's do this. I think the sum of, let's see, the sum of this should be 13, I guess? Yes. So I think this code works. And to be honest, it looks sort of icky for, I mean, that's a technical term, but for a lot of different reasons. One of which is, so this is a contrived exercise using pointer arithmetic. If you actually want to write the array sum function, use subscripting in a for loop. Give me a break. Don't try and write it in an obfuscated way. But here's an example of a way of using pointer arithmetic that results in a pretty, I don't know, cryptic or alien-looking form of code, but demonstrates the power of using pointer arithmetic. Notice how I never need an index variable. Instead, I use this weird cryptic loop that keeps iterating up to this number of times, and at each step, I dereference my pointer and then increment it. Okay, one last flourish. This is really sort of annoying sometimes when people do this, but if for some reason it matters that I write code that's as cryptic as possible, I could even do something like this. Here what I'm doing is leveraging properties of operators to do both the dereference of the pointer and incrementing it in apparently one step. So to be clear, what's happening here is this gets parenthesized like this, and I'll demonstrate that by running it. So the way this works is it says increment the pointer ARR. So I've got my pointer ARR here, and it's pointing off to, in the middle of some array somewhere. It says increment the pointer ARR, but we know how this plus plus operator on the right works. It says send back, so send out of the brackets, the old value of the pointer. So ARR gets updated to point to the next element, but the pointer that comes out of these brackets would be the old value of ARR, the pointer to the previous one, which then gets dereferenced, which is exactly what I was doing before. I was dereferencing the old pointer and then incrementing it. And here, because I'm trying to be cute, I guess, I've decided I want to do them both in one expression and sort of, enrage anybody that tries to read it. But there it is. Okay, so I'm actually gonna back up one step from there. Okay, there we go. And although that's still a little bit ugly, that is an orthodox pointer arithmetic trick I could use for this. And I don't know that it's any easier or shorter or anything else. Arguably, it's actually more complicated. Okay, what about array copy? So I'm going to go back down. I'm going to uncomment the test cases for array copy. And it looks like what's happening here is I've got these two arrays in main. ARR1, that's being used as the source array. ARR2 is being used as the destination. So of course I'll have to make sure ARR2 always has enough space in it for this. And then I've got this variable size that gets passed in. And then it prints out the copied array. So that all looks pretty straightforward. That's the same test case I would pretty much write there. One interesting thing about this function though is the source array is the first argument, which actually does seem rational, frankly. But we're used to, if we think about functions like strcpy, we're actually sort of used to these copy functions taking the destination as the first argument. So that's an interesting, and it's neat that ChatGPT decided to put the source first, because ChatGPT, as far as I can tell, generally does seem to be swayed by popular opinion. So because a large majority of copy function usages are things like string copy and this other function in the library that we don't tend to use very much, but it's for copying arrays that aren't strings, memcopy. They take the destination first. It's interesting that ChatGPT decided to put the source first, but who cares? It did that, so we'll work with it. Okay, so I could write this just like before. I could write it with a for loop. I could say I is equal to 0, I is less than size, I plus plus. And then I could, well, I mean, I could do it the obvious way, the way that I would write it if I wasn't required to use pointer arithmetic, where I say destination sub I equals source sub I, and that would work. You can try that yourself if you don't believe me, but this isn't pointer arithmetic. So what I could then do is I could adapt this to basically use the same technique I used in the previous function. So I use the pointers and then I update both of them. And if I wanted to be obnoxious, which to be honest, outside of teaching C, I often do write obnoxious looking code, I could even write something like this. So this is obnoxious when you're learning the C language, but after you've used C for a long time, you begin writing this because your standards change over time, I guess. For the time being, though, I think it's nice to write this code that's a bit cleaner, it's easier to read, so we'll do the incrementation on a separate line. So I'll try that out. And then I want to do the same adaptation I did in the previous function where I get rid of this for loop, just to demonstrate that pointer arithmetic can allow me to, I don't know, save variables if that really makes a difference. So I'll try compiling that. I'll try running it. So the copied array is apparently 37285. Well, here's the array I was copying, and certainly it is 37285. Let's see what happens if I use, let's do, I don't know, I'm going to do at least one test with a different array that is still of size 5. Okay, there we go. And then let's see, let's try an array of size 6. So I could update this to be size 6. And actually, I could also observe that ChatGPT missed a clever simplification. If I'm using this clever trick to figure out the size of my ARR1, I could just, you know, use that size to create ARR2, so it's always the right size. I don't know if that's going to break one of my future test cases, but let's give that a try. Okay, so it's copying this array of size 6. Can it copy an array of size 1? Looks like it can. So I want to make more simplifications. Just like before, I don't need this for loop. What I could do, and if you try tracing this, you'll agree that this does work. I could just say, well, okay, if size comes in as 1, then if I keep subtracting 1 from size, then it will count, the loop will iterate 1 time. And if the size is 5, this loop iterates 5 times. The size variable becomes useless by the end of it, but it's fine because this function has its own copy of the variable, and it's allowed to destroy its own variables as it sees fit. So I'll try this. In this case, I'm not creating this extra variable I, which, as I said, isn't really a problem. You can make as many variables as you want usually in the compiler. When you have programs, functions that need 2 or 3 variables, it makes no real difference, so you might as well do it. But just to demonstrate that with pointer arithmetic, we can get away with a lot of stuff we wouldn't otherwise be able to. There you go. It still copies that array of size 6. Let's try going back to an array of size 5. All right, and that works. And as I said a minute ago, if I wanted to, I could make this even more cryptic. Actually, let's just try that. Let's generate the most cryptic version of this. So what I'm going to do is I'm going to try and combine expressions as much as possible. So here, I'm going to do the incrementation in the same line as the dereference. And for reasons that I gave a couple of minutes ago, that's valid. First, the dereference actually seems to happen first, and the incrementation sort of happens later. So we'll try that. We'll make sure that still copies. It does. I can even go one further. So what I could also do is observe, hey, here I've managed to have this multi-purpose line that does a copy as well as an incrementation. Why don't I do a comparison as well as a decrementation to eliminate one line of my while loop here? Okay, and that still works. And I could even go one further and do just, you know, the icing on the cake here is because this is now a while loop that's 1 line long, I could get rid of the curly brackets. And I think this function has now reached its final form. Oh, well, I can think of something else we could do. But this function has now reached its final form without becoming so hideous that we don't even want to look directly at it. So what I have here is a one-line while loop that manages to combine the decrementation of the size variable, something that really we were never expecting to have to modify, with the comparison against 0, and the single line in the body of the loop is combining the copy operation itself with 2 pointer incrementations. So this is what happens if we use pointer arithmetic. Now, as I said, if I had to write an array copy function, typically I would probably just use a for loop with an index, and I would use array subscripting. But whatever, we're here to practice pointer arithmetic. Okay, so I'm going to leave it in this somewhat less cryptic form that isn't apparently deliberately confusing. Okay, make sure that I haven't broken anything in the process. Let's go down and try, let's now write our 3 string functions. So test exercise number 3, string length. And this is the string length function from the library, pretty much. Okay, so here I'm only taking a string as my argument. And, you know, I feel like as far as pointer arithmetic goes, you can write anything you could write with indexing using pointer arithmetic. They're interchangeable. On the other hand, these last 2 functions, I've said while I wrote them, these are ugly, these are weird, they're not readable, they're maybe not be maintainable, why would you do this? You may still do it. I mean, that's my opinion, so, and you may not care about my opinion, I guess fair enough. What I will add, though, is that it's actually the case that I think when a pointer arithmetic does make a function look beautiful, when pointer arithmetic actually does result in good-looking code, it is often on string functions. And the reason for that is because the size of the array isn't a separate thing in a string. In the string, the size of the array is sort of built in. It's that null terminator. That's how you know when you've reached the end of it. And so instead of these cases where I've got to somehow loop up to the value of size, which is some separate variable that I then have to manipulate, in string functions, all I need is the pointer. And so if I want to use a pointer arithmetic-based string function, I'll just draw our usual string here. Then I can start with a pointer to the beginning of the string, and I can just march this pointer along as I go, and just stop as soon as the pointer is pointing at a null terminator. And so I'm going to do that for my string length function. And I should add, string length is one of those functions that people often make it a contest to write in as few lines of code as possible, and therefore end up with very weird cryptic implementations. So, okay, the length is going to start at 0, and then, let's see, I guess what I'll do is I'll say while star of str is not equal to the null terminator, I add 1 to my length. And then when I go down here, I return the length. Let's go try that out. Let's look at our test case. Okay, so this is going to be, so this string is of length with its 5, 6, 7, 8, 9, 10. There's 14 up to there. Up to the end of this space is 15. There's 20, 26. The string seems to have length 26. Oops. Okay, so the program isn't running, it isn't finishing. It seems to it seems to still be running. I'll terminate it. That's, to me, that sounds like an infinite loop, and I'll bet what happened is I forgot to increment something. Yeah, I forgot to do str++. So I'm not marching my pointer forward at each step. Try that again. Okay, this time it ran. The string does have length 26, I guess. Okay, so let's do hello world, which will have length 11. So, whoops, hello space world. That should have length 11. Let's give that a try. Sure enough, length 11. All right, and then I'll just do, this should now have length 15. Looks like, oh, 16. Okay, did I make a mistake? Oh, yes, right. Okay, so hello world has length 11, and then the space is 12, and then the extra 4 characters are 16, so I forgot about that space. Okay, we'll just, there we go, good, length 16. Now, let's see how we can make this look cryptic. So, first, I have length plus str plus plus. Well, like what I could do is fold the plus plus directly into the while loop, which, okay, there we go. I've eliminated one line, which changes nothing. The program isn't any faster as a result of this. It's just harder to read, but let's just make sure that that works. Okay, the length is still 16. I wonder if there's anything else. Well, I mean, I could just get rid of this. So I could get rid of the curly brackets to eliminate a little bit of space. Yep, that would work. I could make I mean, I could do there's some shenanigans that I could use to make it to eliminate a line. Well, okay, here's one thing I could try doing. This is way off the radar, but if we want to create a very short string length function, maybe I could try doing it recursively. So I'll just show this off, and if you don't like recursion or don't want to think about recursion, then just skip ahead in the video a little bit. Let's see. So if star of str is equal to the null terminator, so that is to say, if the first character of the string is the null terminator, then I return 0. Okay. And otherwise, well, what's the length of the string going to be? Well, let's see. Let's try and see if we can think of a way of doing this recursively. So there's H, there's E, there's L, there's L, there's O. And here's an observation about strings. If I give you a pointer to this character here, how long is the string? Well, let's see. If you start printing the string starting at this E, you get ELLO. You have no idea whether the string was already, whether you're in the middle of an existing string, whether there were characters before you. It's none of your business. If I give you a pointer to that E, the string you're looking at is ELLO. If I give you a pointer to this L, the string you're looking at is LO. It doesn't matter to you whether there were characters beforehand. That's none of your business. So I could maybe leverage that. I could say, okay, if I'm not already looking at the null terminator, so for example, if you've handed me a pointer to the H, then what's the length of the string? Well, the H certainly counts as one character, so it's one plus what? Well, the length of this bit, the length of the rest of the string. Okay, so I'll return 1 plus string length on the pointer str plus 1. So if you gave me this pointer here, this pointer plus 1 is a pointer to the E. And I'm just going to ask for the length of the rest of the string. Okay, so let's see if that works. And I'm not going to test these exhaustively just because I'm trying out different techniques. Okay, the length is still 16. In case you're skeptical, we'll try one more example. So I'll get rid of this and it'll be length 11 again. All right. Now, this isn't really any fewer lines than what I had before. And so, again, as the icing on the cake, I will reduce this whole thing to one line. And I don't know why this is actually a good idea, but there's something vaguely satisfying about knowing you can write cryptic code. I'm going to use, and I believe this may be the first time in this sequence of videos, and maybe in this entire offering of the course that I have done this, I am going to use one of my close friends, the ternary conditional operator, which is a way basically of condensing an if statement down into one expression. So I'm going to use brackets for this. I don't actually have to do that, but I just like using brackets around these conditions, so I'm going to choose to do so. The ternary conditional operator is where you put something that evaluates to a condition, so basically any integer expression, but usually some kind of comparison on the left-hand side. Then you put a question mark. And remember that this will either be true or false. And after the question mark, you put what value you want to come out of the expression if the answer is true. Okay, so if star str is the null terminator, then I want to return 0 because I'm in the return statement. The value of this expression will be what I return. So if star str equals null terminator, I want to return 0. Otherwise, so you put a colon, so the question mark is after the condition, then afterwards you put what happens if the condition is true, then you put a colon, and then you put what happens if the condition is false. So if the condition is false, I want this. I'll just bring it right up there, and then I'll get rid of the curly bracket. And then we'll try running it. Okay, the length is 11. And I'll try another test. We'll add back these extra 5 characters. The length should now be 16. And so, behold, an absolutely cryptic and frankly almost a little bit disgusting looking implementation of the string length function in one line of code. And not just one line of code, because we know that we could put the whole program on one line if we care about it, but one return statement with one rather complicated expression on its right-hand side. Okay, fine. So apparently we can use pointer arithmetic. Now let's undo a bunch of steps back to a version that I think is sort of remotely civilized. So I'll keep going back until we have the version with a while loop. Although the recursive version is actually very in my mind, now that I should backtrack a bit on that. This version here, I think, is actually more civilized than the other pointer arithmetic version. Recursion is considered a pretty classy thing, so in my opinion. Although if you ask many of my colleagues or other computer scientists out there in the world, I think they'd agree, recursion's a pretty classy deal. So this is pretty nice, but in case we don't want to look at recursion today, let's go back to the while loop version. You're always welcome to write recursion in this course, although a study of the uses of recursion doesn't tend to happen in much detail until the next programming course. So I'm going to go back to this first, which I think is quite nice. Okay, I'm going to get rid of my diagram. We'll just try running this one more time to make sure that the version I ended up with actually works. Okay, I'm going to assume that means it does. And then we can move on to string concatenation. And here what I want to do is I want to copy all of the characters from str1 into my destination string, then all of the characters from str2, and of course then a null terminator. So what I basically want to do is string copy, but twice. Now I've got this array copy function which gives us sort of a flavor of what I want. I just want to essentially do string copy twice in a row, once to pull in characters from here and a second time to pull in characters from here. This is a function that I'm going to test incrementally. I'm going to begin by testing that it can copy str1. I'm going to stop, do some testing, and then come back and do str2. All right, so my idea here is I'm going to use pointer arithmetic. I'm going to draw the same string I've now drawn like 1,000 times in this series. There's my string. And I've got this big destination array. And I say big, but on the other hand, I actually don't know how big it is. It's the caller's problem to make sure that the destination array actually is big enough. So I'm not going to worry about that. I'm going to assume the caller knows that it's passing me two strings and knows that the destination needs to be big enough to contain the characters in both of them. So what I'm going to do is I've got a pointer str1 to my string str1, and then I've got a pointer to my destination array. And what I'm going to do is just walk them both along in steps of one, just like I did in my array copy exercise, and copy characters over from one to the other. When I'm done, though, I'll actually already be set up to start copying my second string. So when I'm done, I expect my destination pointer to be stuck at the next available character after the end of the stuff I just copied. I can then use that as the beginning for the next phase of copying when I get there. I'm going to leave the diagram up because I probably am going to want to draw more stuff, and then I'm going to write the while loop to do that. So the while loop that I want is basically I want to walk along with str1 until I hit the null terminator in str1. So I'll say while star str1 is not equal to the null terminator. Keep moving, and let's see, I want to say star destination equals star str1, and then increment both of them. And we know by now the trick I could try where I do the incrementation inside of this expression here. But because we already know that we can do that, I'm not going to bother doing that. I'm just going to, you can use your imagination or you can try it yourself. Now, at the moment, I'm not ready to start copying my second string. I just want to test out what I have. So when I'm done, the destination string should look sort of like this. Notice that it's missing something pretty important because I'm not done the function yet, but I'm going to need to add it if I want to test the function. What I need to do is, when the loop is over, my destination pointer will point to the next available space in my destination array. I'm going to set that to a null terminator. Just so that I can test things out. So destination, star destination. I follow that pointer and set whatever's at the other end to be a null terminator. All right. And so I'm going to test this as is, and then I'll come back and test out that I can copy in the second bit. Okay, so here's the test case. It looks like my first string is the word hello, comma, space, okay, and then pointer arithmetic. And then you can see how ChatGPT's even added a comment here saying, make sure the buffer is large enough to hold the whole string. So that's an acknowledgement that it is main's problem to do that. The string concat function has no way of knowing the size of the buffer, so that means it's not the string concat function's fault if the buffer is the wrong size. Okay, so I'm going to run this. All I expect it to do is print out this bit here, hello, comma, space. And I'm going to have to take its word for it that the space is getting printed because it's a space. All right, actually I could do some square brackets here so that I make sure to see that space at the end. All right, looks like that works. Okay, with that quick test done, I'm somewhat confident that I don't have any obvious problems with my methodology, and so now I could continue and work on copying str2. So as of the end of copying str1, so I'm going to think of that being sort of line 66, what I have is the destination pointer is already set to the first place to put the next character, the first character of str2. So now I've got this str2. Let's suppose I'm copying the string world. And so there it is. And str2 is a pointer that points to the beginning of this string. What I'm going to do is basically copy and paste this loop. I'm just going to walk along with my str2 pointer until it hits the null terminator in that string, and just copy them into every character starting at the current position of my destination pointer. And so I'm actually going to run literally the same loop, except with str1 changed to str2. Now, this is an example, I think, where if you wrote this with indexing and no pointer arithmetic, it would actually potentially be more complicated. The advantage here is that because the destination pointer gets moved as I go, when I start my second phase, the destination pointer is already set up and ready to go. I don't need to do any weird thing with an offset index like I would have to do if I used indices for this. And so as a result, I can literally copy and paste. I wouldn't be able to literally copy and paste the loop if I were writing the index-based version of this. Okay, so I'm going to try running this. Okay, it prints out hello pointer arithmetic. And so now I'm ready for some actual testing of this case. I'm going to get rid of this junk in the string length test case. Okay, so let's see if we can copy hello world. So I'm going to try making both strings a little bit shorter. All right, we'll see what happens. I am going to add the square brackets to this output because I want to be able to see if any junk gets thrown into my string at the end. Okay, hello world. Let's see what happens if my second string is only one character long. Because I know that it's not manipulating the characters themselves, I'm not too worried about testing it on things like uppercase, lowercase, digits, and symbols. But I am going to test it on different lengths of string. Okay, what happens if the first string is just a space and the second string is hello world? Okay, looks like that works. What happens if the first string is completely empty? Okay, looks like it still works. What happens if I swap that and have the first string have stuff in it? I'll leave in that typo. And then the second string is completely empty. Looks like it also works. All right, so I've tested it on a few different strings of different sizes. The test case that ChatGPT gave me also had a bit longer strings in both cases, so I can be reasonably confident now that string concat works correctly. So I'm going to get rid of my diagram. I'm going to undo all of these changes to the test cases to bring us back to the one that it gave me to start with. There it is. And if I scroll up, so there are ways I could simplify all of this down to, well, okay, I'm tempted. I would like to show off the most cryptic version of this. I'm just going to show it off briefly. So what I could do is compact all of these loops into weird one-line while loops. So I could try something like this. There's also something else I could do. If I had a string copy function available, I could also use that for this purpose. But what I could do is I could take this entire these entire two while loops and condense them down into these disgusting looking things. I could even go one step further. If I wanted to get rid of this, so that adding a null terminator at the end, I could add, oh, let's just try it. Okay, what you're about to see is something that is not only an acquired taste. I mean, to say it's an acquired taste implies that it's edible, which it sort of isn't. This is a very weird idea, what I'm about to try, but I'm so intrigued. As you can tell, I'm fascinated by playing around with pointer arithmetic. Let's see what I can do here. Let's try doing this. So what I'm doing here is I'm making it so that in all cases, it copies the character. Even if the loop is about to end, the character gets copied anyway. And that should mean, I think, if I've done everything correctly, that I no longer need that line that adds the null terminator. Now, why this works, I'm going to leave, if you really want to know, I'm going to leave that as a tracing exercise. But now I'm going to go, we're already past the point of no return, so I'm going to show off an even more cryptic. I think I'm going to put this function in its final form. What I could do is observe that I've taken this copy operation and bumped it up from inside the loop into the condition, which is very weird. Why not bump the incrementations up as well? If I do this, there's nothing, I don't need anything on the inside of the loop. So I could actually just make the loops completely empty, which is really weird. So, I mean, what I've basically written is a while loop with no body. In C, you're allowed to just put a semicolon there to say, sorry, there's nothing to do inside the loop. Just run the condition until the condition fails. And we'll see what happens if I do that. And that, oop, that didn't work properly. Okay, so let's see. Well, destination plus plus is not, oh yes, okay. So I'm gonna just back up a couple of steps here. So because this is an unholy travesty, maybe I won't try and go into much more detail there. There's one thing I missed there, which is if I okay, I've got to get back to the state where the loop was still intact. So if I put it back in this state here, where the loop still works. All right. So if I want to do the incrementations in place of the loop body, so if I want to delete the loop body, I've got one loose end that I have to tie up, which is that between the two loops, the destination pointer gets pushed a little bit too far forward, and I've got to find some way of pushing it backwards. And that means I don't end up with as well, it's just as cryptic, but it's not as compact as I was hoping. Now, I'm not going to go into much more detail on that. There is a way of shortening this down to being, I guess, 2 lines plus one extra little adjustment statement. But okay, we'll leave that in and then just move on from there. In fact, actually, I'm going to back this all the way up into the last civilized version. So we'll go back to our nice 2 while loops, the kind of thing somebody in 111 might be expected to understand. Although, as usual, if you're given a midterm question involving string concatenation, you are always welcome to use square brackets. And if square brackets make sense, then you should use square brackets. Okay, so let's go down and do some more exercises at the level of this course. Let's get into string compare, and then we can finish off for the day. So string compare, I'm going to uncomment the test case for that. String compare is this is trying to prompt me to write the strcmp function from the library. And the way that this function works is you give it 2 strings and you return an int, and the int is either positive, negative, or 0. It is negative, and actually the test case is pretty good at showing this off. You give it, so here's 2 strings. Notice that in a dictionary, the word apple would come before the word banana. So we can think of string 1 as being less than string 2. And so strcmp, the string compare function, returns a negative number if the first string is less than the second string, which again for strings means it comes before that string in the dictionary. It returns a positive number if the first string comes after the second string, and it returns 0 if the 2 of them are equal. Now, the way that we evaluate this is we just go through each string character by character. So in this case, we start by comparing the A to the B. If the 2 characters are different, then whichever character has the smallest character code or numerical value, that means that the corresponding string is smaller. So in this case, the A is smaller than the B. So string 1 comes first, and I'll return a negative number. If I were to do it in the reverse order, if banana was string 1, then B comes after A, so I would return a positive number. So I'm going to need to make sure I test this carefully, but basically what I want is a loop that goes over both strings, column by column, and then compares the characters. If the characters are not equal, the function is just over. It returns based on the values of those characters. If the characters are equal, then it moves on to the next one. If it hits the end of one string before the end of another, then again we go to dictionary order, which in the dictionary, for example, the word cat comes before the word catastrophe. And that's because they obviously are identical up to the end of the 3rd character, and then one of them just sort of ends. And so in a dictionary, if you've got a word that's a prefix of another word, you put the shorter word first. And so we're going to use that logic as well. Okay, so I want to write a loop that walks through both strings sort of in unison. And so what I'll do is, I guess my logic is if I have 2 strings, then I'll expect each string probably contains at least 1 character, although it doesn't have to. What I'll do is I'm going to keep walking. I'm going to move both pointers forward. This is probably a pretty easy function to write using indexing. I'm going to move both pointers forward by 1 as long as both pointers are referring to a valid character. As soon as one of them is pointing to a null terminator, then I'm going to stop. And then I've got to worry about a couple of special cases. Okay, so my while loop is going to say something like, as long as str1 is not equal to the null terminator, and whatever str2 points to is not equal to the null terminator, then I want to keep moving. And what I do at each step is I look at the characters and I say if star str1, if the character in string 1 is less than the character in string 2, well, then I'm done. Because as soon as I find a character in str1 that is smaller than the corresponding character in str2, I know that str1 is less than str2. And if it's less, I return a negative number. Okay, so I'm just done. I return -1. And conversely, if I notice that str2, or well, we'll do greater than, str1 is greater than star str2, then I know that string 1 is now greater than string 2, so I return 1. And I just stop here. I don't need to compare any future characters. I know that apple comes before banana because apple starts with A and banana starts with B. If I were to compare strings, so if I want to compare apple to aardvark, well, in that case, I look at the first character of each of them, the A, and they're tied. So I keep going and check the second character. Then I see the A and the P. Okay, A is less than P, so aardvark comes before apple. So I only return if I've resolved the situation. Otherwise, I keep going. I don't return anything. And then I have to increment both of my pointers. So str1 plus plus, str2 plus plus. Okay, it's complaining about a couple of different things. Oh, let's see. It seems to be giving me a complaint about line 73. Oh, yes. Okay, so when I was cleaning up this function a minute ago, I guess I forgot a curly bracket. I forgot to compile and test that. It looks like I have still not fixed it. Okay. Just save this again. I'll just compile it. See, this is why I should have retested my code. There it is. Okay, now I fixed it. Okay, so now string compare is currently not finished because I still have to return something down here. So what I'm going to do now is I'm going to say, look, if I get out of this loop and I wasn't able to find any combination where one character is less than another, I'm going to tentatively say maybe that means the words are equal. Now they aren't. I've omitted a special case that I have to come back to, but I want to be able to test this on something. All right, practice pointers 4. Okay, so apple comes before banana. Now let's do a few tests. Let's verify that banana comes before apple. Okay, so banana comes after apple. Oh, whoops, yeah, okay, banana comes after apple, obviously. Let's now consider apple or banana and band. Okay, so here, so I actually expect banana to come before band because it's tied on the first 3 letters. On the 4th letter, A comes before a D. Okay, so that I should expect banana to come before band, and it does. That's actually, that may not always be the case. So I haven't yet implemented logic to handle short words over longer ones, but we'll get there. Okay, so let's do apple and aardvark. So I expect apple comes after aardvark because AP comes after AA. Okay, and it does. Now let's do catastrophe and cat. Okay, catastrophe is equal to cat. Now, that's obviously false. So what's going on? What's happening is this loop continues only as long as I'm looking at a valid character in both strings. The problem is, if I look at catastrophe and cat, one of the words is longer than the other. And that means that if I consider where the null terminators are, so my pointer str1 ends up pointing here eventually. At the same step, str2 points here. And the loop ends because it says it only continues while str1 is not equal to null terminator and str2 is not equal to null terminator. But in this case, str1 does point to a null terminator. So we just stop. But obviously, there's still something left to litigate. We're not done making this decision. So what I have to do now is consider what happens if both strings haven't ended. If both strings have ended, then the words are equal. So if there was a null terminator here, then I'm actually comparing the word cat to the word cat, which that means they're equal, so I return 0. But if there's anything other than a null terminator here, the longer word is greater. So the way I'll implement that is by asking where the null terminators are. So if star str1 is equal to a null terminator, well, that means that str1 is, so I'll just write it, str1 has ended, but str2, maybe I should invert this criteria. If str1 is not equal to a null terminator, that means that str2 has ended, because if the loop ended, at least one of the 2 strings definitely has already ended. So if str1 hasn't ended, then str2 must have ended. So it means str2 has ended, but str1 has not, which means that str1 is longer than str2, so str2 comes first. If str2 comes first, that means str2 is less than str1, or I could write that as str1 is greater than str2, so I return 1. Okay, and then conversely, if star str2 is not equal to the null terminator, then that means that, well, at least one of the strings has already ended by the end of the loop, which means that if it wasn't str2, then str1 has ended. str1 has ended, but str2 has not. So therefore, str1 is less than str2, so I return -1. All right, if I get all the way down here, then both of these if statements would have had to evaluate to false, and that means both strings have ended. And there is a tie. Therefore, str1 is equal to str2 in a broad sense. I shouldn't be using these pointer names. I'll call them string 1 and string 2. Because obviously the pointer str1 may not point to the same place as str2, but I'm talking about the string in a broad sense. So I'll do this. And then I guess also I should put equals equals there. Just replace all of these. There we go. Okay, that looks better. Okay, so that means that they're equal, which means then I can return 0. Okay, so I'll try this out. Okay, catastrophe comes after cat. Okay, so that's what I expected. Let's try banana and ban. So obviously ban is a prefix of banana, which means that it should come before banana. So banana comes after ban. That's right. Let's try the converse case. So ban and banana. We'll try that. Okay, ban comes before banana. What if I compare cat to itself? I obviously expect those two things to be equal to each other. Looks like they are. We'll try one more. I'm actually thinking back to my own string compare exercise that's posted elsewhere. Let's try comparing raspberry to raspberry. Okay, they're equal. Okay, I think I've now completed the exercise. I've done enough testing to verify that all the different cases I wanted to exist seem to work. They come back with the right answer. And so now I'm done my set of pointer arithmetic exercises. Okay, having said that, as a completionist, I would like to now go back and address that weird thing I was doing in the middle that I gave up on for the sake of moving things forward. So if you don't care about this weird simplification I was trying to do to this function, then now's the time you stop the video and go do something else. But let's finish the process of fully simplifying this function to the most disgusting cryptic form that we can. Well, or 2 lines or 3 lines and then leave it there. I guess we could make it even more disgusting if we tried really hard. Okay, so I'm going to go back and I'm going to again produce the version where I do the incrementations in line with my assignment statement. There we go. And so I can delete these. And so we'll call our attention to this line here. That is where the test of string concat is being done. I'm going to put the result in the square brackets because I want to be able to see any junk that shows up. Sometimes it's invisible, sometimes it's just spaces. So I'll try that out. There we go. It looks like it's still working. And now what I want to do is reproduce that case where I was somehow doing the assignment in the condition for the loop, which we know is something I'm allowed to do. I can put any expression I want in the condition for the loop. And the idea is I'm first taking the value out of the pointer string 2, putting it in my destination string, and then what comes out of this set of brackets is the new value I just assigned, which will in some cases be a null terminator, and that's how I know to end the loop. So I'm going to do that here as well. There we go. I'm going to try running this. Now, this was the version that we saw did work, and it allows me to eliminate this null terminator here, and I can, or to eliminate the explicit statement that added a null terminator. To be clear, this array is still getting a null terminator. The function would be wrong if I don't make sure a null terminator ends up there. If you try to trace this, you will observe that indeed a null terminator does get installed in my destination string before the function is over. So I'll try that. It looks like that's still working. Okay, so now the place where things got messed up. So I was trying to do this, where I delete the body of the loop completely and try and fold literally everything into my conditions. And then it broke. And then I backed everything up because I figured this isn't necessarily a rabbit hole we want to go down. But now that we're at the end of the video, why not take a look at it further? Let's go back a little bit to the version where we have the one-line loops. Okay, there it is. Let's see how much of what I was doing I can get away with. So I'm going to try this. I'm going to try converting the second loop to be this condition-only form, this really weird cryptic form. And we can see here, it does appear to work. So what exactly was happening when I converted both loops to this? It's weird to have this asymmetry. And the idea basically is this. So at each step, I'll just, for the last time, I'm going to draw this diagram. Last time in this video, at least. Okay, so there's my string hello, here's my destination string. So I've got my pointer str1, I've got my pointer dest, and what the loop condition is saying that I need to do, let's actually go back to the one-line version of this loop, the one where I don't even have a loop body. This loop condition is very dense, it's very cryptic. What the condition is effectively saying, what I'm doing inside of these brackets is, I'm saying, okay, go grab the current character that's pointed to by str1, and then when you're done grabbing it, increment the pointer. So I go grab the character h, and then position this pointer at e. So this is the str1 pointer. I then take that h, the thing I just grabbed, and I assign it to this. But this expression says, basically, use the location destination currently refers to, so I use it by assigning h to it, and then add, whoops, weird, then I add 1 to my destination pointer. Okay, so there we go. And then I do that again. So I copy the e, and then I move this pointer, oh, whoops. Before I copy the e, I want to just make one other observation, which is that I actually didn't finish evaluating my condition. So once I'm done with performing the copy, I take what comes out of these brackets, which as we know will be the value I just assigned, and then I will compare that to null terminator. In other words, I'm actually asking here, if I just copied a null terminator, then stop. But I didn't. I copied the h, so I don't stop. And I'm just pasting things by accident here. I copied the h, so I don't stop. Okay, so now I copy the e. I move this forward. I move the pointer forward from here. I copy the L. I then move this pointer forward again, and then I move this pointer forward as well. I copy the second L, and then I copy the O. And at the end of the step where I just finished copying the O, both pointers are now stuck at the position right after the O, so here. Let's see what happens with this loop at the next step. Okay, so at the next step, I say, grab the current character pointed to by str1. Well, that's the null terminator, okay? Increment str1. Now, this isn't going to matter much because I'm not going to need str1 again after this, but str1 now points past the null terminator, which isn't inherently wrong as long as I don't try and follow that arrow. Now, take the character we just grabbed, that was the null terminator, and assign it to this location here, star destination. That would be putting the null terminator in star destination. Notice that's actually pretty clever. Besides looking horrifying, that's pretty clever because I don't need to add the null terminator myself. Okay, so I'm not done though. I then have to increment destination. So I do that. And then I begin my second loop. Maybe you can see where the bug is. So when I begin my second loop, the problem is my destination pointer is pointing a little bit too far. I've got this null terminator that I inherited from the first string that I've copied into my destination string and I can't get rid of. So what do I do here? Okay, well, there are probably a few ways you could approach this. I could even try some shenanigans with where I put the plus plus operation. But I think the way I'm going to solve this, and I think it still keeps things nice and cryptic, is I'm going to add this. I'm just going to back the pointer up a little bit between loops. So at the end of the first loop, I just do a minus minus, and then the destination pointer starts here for the second loop. So I then copy the first character of the second string over that null terminator so that I can continue the concatenation. So we'll try that. That is not the only way of doing this. There is another way I can think of a couple of other options that are more cryptic, and maybe that's what we care about at this stage in the video, but there it is. So here I have a 3-line implementation that is disgusting, that isn't maintainable code, why not just write readable code? It's all going to be the same in terms of speed, frankly. You're not saving any time for the processor by mashing everything into one line like this, because the amount of time the processor takes is based on how many operations are being done, not how many lines of code you wrote. Additionally, the processor's time is basically worthless. It's much better to save human time than computer time. Okay, whatever. Here's your cryptic 3-line string concat that nobody can read. Are you happy now?